I bet your bitch ass never even paid attention in school. Or, matter of fact, probably forgot all the lessons you learned from your teacher. Like, what the fuck are you going to use y equals mx plus b? Or a squared plus b squared equals c squared? When the fuck? This theory that everyone is definitely gonna use and is probably gonna help you in the real world is the Bayes theorem. And let me show you how it works. Now, you're probably seeing from your screen right now some weird ass formula. Now, this one close to the equal sign, that is events. Well, those other things on top of the probability B is likelihood times prior probability. But what's under the prior probability and likelihood is the total amount of evidence regarding that probability. And if you want to know how it works, I have this random ass example that I found from YouTube. And not only it helps in the real world, but can also help you learn about the Bayes theorem. But before that, credit to my boy Ace Tutors for telling us this problem. I don't know if Ace Tutors the only person that knows the problem. So if you know a person earlier that said this problem, please leave it in the comment. You've been planning a picnic for your family. You're trying to decide where or not to postpone due to the rain. The chance of rain on any day is 15%. The morning of the picnic, it's cloudy. The cloud of it being cloudy is 25%. And on days where it rains, it's cloudy in the morning 80% of the time. Should you postpone the picnic or not? But let's find the prior probability and the likelihood. The prior probability, which is cloudy in the morning 80% of the time, that is the prior probability. And the probability of rain, that is the likelihood. The likelihood of it raining is around 15%. And last but not least, the total probability of evidence. We're just going to use the 25% chance of being cloudy. If you times 0.8 and 0.15 divided by 0.25, actually I just use a calculator. Hold up. Yeah, do all those and you get 48%. Or better yet, 0.48. Now I bet you're thinking, wow, that's pretty cool information. I am totally gonna use this for everyday occurrence. Or you're probably thinking, what the where the do you get these numbers? Well, first of all, I got it from a problem. But to solve your problem, I'll just give you another problem. I made this up by myself. So listen up. Let's just say that people claim that there is a 3% chance you might get laid. And the likelihood of unattractive people getting laid is around 80%. But then again, those 20% of those mother effers never even got laid. What is the probability of getting laid given the fact that you ugly as? Now first, let's find the elephant in the room. I'm not talking about your wife. Let's find probability B, but we'll call it probability G. The reason why we need probability G is so we can multiply the likelihood and the prior probability divided by probability G. Let's do the same thing in the formula, but instead of dividing, we just add and multiply those false positive numbers. Remember the 20% of the people that never got laid? We're going to use that number and times that by 0.97. Now you're probably wondering, where did I get 0.97? Do you remember that there is a 3% chance of getting laid? If you do 100 minus 3, you get 97. We call it probability not A, but I just call it probability not P. And if you should probably get this. If not, you can obviously copy it from your screen, but you ain't gonna learn. Now, once we find what the equation equals, we can still multiply the likelihood and the prior probability, but this time divided by the given number that we got from our equation. By doing this, we should get an 11% chance of getting laid given the fact that you're unattractive. Keep that in mind, guys. Everyone has hope. Just remember that. Because all of those numbers I did, I just made that all up. The reason why I made it all up is because I want to make math problems. No, wait.